All right, today we're going to talk about conversion between numbers and bases, right? And so I have this table here that we start with base 10. Base 10 is the typical way we count. And we start with the number 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Well, if we think of it the way we're going to do it with computer conversions, is we start with 0. If you use your fingers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can't see me, but I just counted my fingers. When I get to 10, when I get to 9, all 10 fingers are up. So I have to start over with my fingers. So really what we're doing in the tens place is we're starting over. We put a 1 for the tens place, and then we bring down and start at 0 again. And so if I look at the ones, I go through 0 through 9 with the 1 being in the tens place. Then I get to 20, and I again put a 2, but then I start at 0, and if I left all those, it'll be 1 through 9 again. So the same thing works with these other bases. Right? We're going to skip base 2 for now, which is called binary. So we start with 5. So we go 0, 1, 2, 3, 4. If again, I count with my fingers, all 5 of my fingers are up. So I start over with 0 here again. 0 again. But I got to put a 1 in. So there is my tens, for lack of a better word, but it's in the 5th spot because I'm in base 5. Then I start again. I put a 1, and then a 1 for technically 11, and then I'm still in a 1, and then a 2, a 1, and a 3, a 1, and a 4. And again, if I count my fingers, 10, 11, 12, 13, 14, I got to start over. So 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. Again, we're done all my numbers. So then I go to 3, 0, 3, 1, 3, 2, 3, 3, 3, 4. And I start over, 4, 0. So instead of going all the way out to 10, I am going out to 5, and I restart over. And if you look at it, I start over of every number that is divisible by 5. So if we do base 7, I can do the same thing. So I start 0, 1, 2, 3, 4, 5, 6, and then I start over. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Start over. 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. Oops, went too fast. 2, 4, 2, 5, 2, 6. And the next one will be 2, 7. Again, all divisible by 7. Same base 8. 0, 1, 2, 3, 4, 5, 6, 7. And then I start over. 10. 1, 2, 3, 4, 5, 6, 7, 2, 0. 1, 2, 3, 4, and so on. And I'll explain here in a second when we do base 16. Now you notice we've only can go up to 10. So you're going to notice a weird part here with base 16. Right? We're going to start the same way we always do. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now here's the problem. If I go to 10, technically, as we've been doing these, that is where we start over. But I can't start over because I haven't got all the way to 16. So what I switch to is the alphabet. A, oops, not tab, B, C, notice I'm capitalized, D, E, and F. Helps if I actually push down and stuff, sorry about that. F. And then I repeat. Now I start over. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and I continue on. So now, instead of creating this huge long, oh, sorry, I forgot about binaries. So the reason I'm doing some of these is, and they're in the book, I like to draw. Put my highlighter, base 2, click on my highlighter, base 2, base 8, and base 16 are common computer-oriented bases because a computer counts in binary, which is what we call base 2, and 8 and 16 are divisible by 2. And so that's why those are some of the common ones. So now if we do base 2 repeats very often. I lost my cursor because I put it on my draw. There we go. And because it repeats every 2 numbers, so 0, and then a 1, and then 2 becomes 0, 0. Actually, I'm going to put all that, we'll just call it, we'll start repeating. Again, it repeats, so that it becomes 1, 0, 1, 1, and then, remember, there is no 2, so this is where it gets tricky. I now have to put in a 1, 0. But I can't make him different than the other one, so now I put in another 0. And then I do a 1, 0, 1. And then I go to 6. And again, I have to start over. So 6 would be 0, 1. Sorry, I'm actually looking at these because they're a little tricky. 1, 0. And that's why you definitely want to have notes for these. And then 0, 1, 1, 1. And then 8 would be, looking for my page. Oh, that's why. I just found a discrepancy. Did I mess this up? 4 is 100. 5 is 101. 6 is 110. Oh, I accidentally put that 0 first. Sorry, that's why it's messing me up. There we go. 110 and a 111, and then I get to 8, and he becomes 1,000. There we go. Now I get the pattern. 1, and then 1, 0, 1, 0, 1, 0, 1, 1. 1, 1, 0, 0. Keep losing my place. 1, 1, 0, 1. 1, 1, 1, 1. And now I start over. 10, 0, 0, 0. 10, 0, 0, 0, 1. All right. As you see, it gets really tricky here. And so what we're going to just do is, oh, I messed up. 16 should be 10, 0, 10,000. 15 is all the ones. Where did I mess up? I got to repeat here somewhere on. Now 14. I forgot to start at the 0. And then 15 is the all ones. Yeah, the binary is tricky. I'm going to show you probably what I think is an easier way to do it than memorizing how to fill in a table. And then 18, 10, 2, 1, 0, and 10, 1, 2, oops, 1, 0. So I'm calculating myself, so I'm messing up my zeros here. And so on. All right, let's get off those. It's getting tricky. Let's see how we can develop these in a much easier way. So if I want to go from base 10, instead of creating this giant table, onto any other base, actually we'll do this one's a little bit easier, converting any base to base 10. So first we write out an expanded notation. So say if we have 1, 3, 4, 2 to the base 5. So this thing right here is called a subscript. and that subscript is the base, okay? And so first it says step 1, write out in expanded notation with exponents. So this is going back to what we had done prior, where I take, so remember we do the 1 times, because that's the first number, right? There's my 1 times, and then it's count the places. Remember, this is 0, 1, 2, 3. So that becomes 5 to the third. This is what we learned in 4.3. Everything in 4.3 was to base 10, though. Now we're doing base 5. So 5, 3. And then we put in our plus. And we use the next number, 3 times. And again, 5, because that's our base. And then it says in the second spot, plus 4 times 5 in the first spot, plus 2 times 5 in the 0 spot. So now I have out my exponents. So there's step 1. Right? And then step 2, then calculate the exponents. And so you may need a calculator. So again, we learned that in 4.3. So this becomes 1 times 125 plus 3 times 25 plus 4 times 5 plus 2 times 5 to the 0 power was 1. And give me a sec, I gotta move my notes down. I don't write over them. Go back to my draw. And now we can do the multiplications. So I get 125 plus 3 times 25 is 75, plus 4 times 5 is 20, plus 2 times 1 is 2. And now I add these together. 125 plus 75 is 200, plus 20 is 220, plus 2 is 222. So I've gone from a base 5 number to a number to base 10. All right, we don't have to write a 10 there because that's how we write our numbers, but technically you could. And that's that becomes 222. All right, I'm going to scroll to the left here so I don't have to mess up my notes, and we can do another one. Binary is computers, and since most of you are interested in computers, that's why you're taking this class, we'll do a binary one. So say we have the binary number 10111110 squared, right? And if you don't know binary, I'd definitely look it up if you're in a computer, so you have a little bit of background in binary. Computers talk in zeros and ones. 1 being off, 1 being on, 0 being off. And so this is how computers talk. When we type in things into a computer, it's actually not seeing what we're typing. It's understanding these, and so the code, like Python, C++, and all that, is a way to write code that does allow a computer to see these things. Sorry, a little phlegmy today. But now we do the same thing, right? So I'm going to change my color here just so we can easily see it. So this is the zeros place, the 1s, the 2, 3, 4, 5, and the 6, right? And then I'll go back to my black. And why I do that is because those red numbers will become my exponents. And now everything's to the base 2. So my first number is a 1. So I write a 1 times 2 to the 6th exponent, which is right up there. Right, so this, just so we can highlight some things, this 1 is this 1. And we'll change this guy to yellow. This 6 is this 6. And we'll do kind of a gray. We'll do purple. I'm going to change it to purple, okay? And then the 2 is this 2, right? That's where you're going to be really careful because the binary is a little trickier because all I have is zeros and ones. All right, so then I add 0 times 2 to the 5th plus, and I'm going to highlight all these because it'd be hard to see. Now I'm in the 4th place, so 1 times 2 to the 4th plus 1 times 2 cubed plus 1 times 2 squared. I'll scroll over a little bit. Plus 1 times 2 to the first plus 0 times 2 to the 0. I think I got it all. Double check. So I was writing 1, 0, 1, 1, 1, 1, 0. Now, 0 times anything is 0. So technically, I don't need to write those zeros in there, but I did so we can see the places. But when you get comfortable with this doing binary, the zeros, 0 times anything is 0. So I really don't care about the fifth place or the zeros place when I'm going to base 10. I do when I'm in base 2, but I don't so much in base 10. So now I just have to go to my calculator. All right, so and write this out. 1 times 2 to the 6 is 64, plus 0 times 2 to the 5th is 32. It's a time, so be careful with your points that you don't think they're decimals. So 1 times 2 to the 4th is 16, plus 1 times 2 to the 3rd is 8, plus 1 times 2 plus 0 times 1. Again, that's times, not a decimal. Now we just add these up. And 1 times anything is itself. So 64. I'll write it just so you can see this was a little neater. Plus 16 plus 8 plus 4 plus 2. Right? 64. Oh, I wrote that it was an exponent, and I should have wrote a 32, not a 3 squared. 32, there we go. 0 times 32 is 0, so that's why I put the 32 in. 16, 8. Did I miss one? Oh, I did. Wow, I went too fast. This guy, I missed him. So plus 1 times 4 plus. There we go. Not going too fast. So 8 plus 4 plus 2. And now, if I add these together, 64 and 16 is 80. And then plus 8 is 88. Plus 4 is 92. Plus 2 is 94. So our binary number we started with of 10111110 squared is 94, which means that if I brought up my table to the 94th place, that is the binary that is in that spot. So that would be much easier than doing that little table. Now, to convert a base 10 to another base, this is where it's a little trickier, right? And so I'm going to use a number we've already used so that we can see how it works. So I'm going to take 222, right? And we want to convert it to base 5. So we're going to divide by 5. And this is where you go to your calculator. 222 divided by 5 is 44.4. And you could do long division if you want. I wouldn't recommend it unless you really enjoy long division, right? Because I'm not testing you on long division, I'm testing on you converting. So use a calculator. And now what you can do is if you take that number, 0.4, the decimal, and multiply it by 5, so 0.4 times 5 is 2. So I get a remainder of 2. Okay? That's going to be key. This is going to be part of our answer. The remainders are what we care about. We're doing these steps to find the remainders. So now what I do is I take this number as a whole number and I write it down here. So 44. Don't care about the decimal. I've already taken care of the decimal with the remainder. So 44 divided by 5, which equals 8.8. And again, now I'm going to take 0.8 and times that by 5, right? So how did I get this guy right in here? This was 5 times 0.4. And now I'm going to go back to my red. So red 4, because 5 times 0.8, the decimal piece, will give me 4. All right, and now I do it again. I take this number, bring him down, so that's 8 divided by 5, So 8 divided by 5 is 1.6. I change my colors because I was like a variable. Remainder. So 0.6 times 5 is 3. And I'll write this out so we can see it again. Be consistent here. 5 times 0.6. All right. And then this guy down, 1 divided by 5 is 0.2. And now I got a number less than 1, so I know this is my final step. And I multiply them together, which gives me a remainder of 1. Now did I get that? That was 5 times 0.2. Now, the tricky part is I read these. I'll go blue. I read these until the numbers are, or I write my answer in reverse order. So in other words, I go this direction. So my answer is 1, 3, 4, 2 to the base 5. And if I scroll all the way back up here, 1, 3, 4, 2 to the base 5 gave me the number 222. So the first part was how I went from base 5 to base 10. The second part is how I take any number in base 10, our number system, and turn it into a base I like. So let's do another. Let's do our good old friend 94, right? Because binary, again, is what we like. So I'm going to start with 94. And I'm going to divide him by 2 because I'm doing binary. Which equals... No, I forgot to write down what that equals. No, 47. Goes in perfectly. It's an even number. So the remainder is 0. There is no decimal. The remainder is 0. So now I bring him down. 47 divided by 2, which equals 23.5. Now I do have a decimal, which is going to give me a remainder of 1, because 0.5 is a half. What is half of 2? 1, right? It's good news is for binary, it's only 0 and 1s, which is what we're going to keep getting. If I get a decimal, it's a 1, and if I don't get a decimal, it's a 0. So now I bring him down. 23, odd, divided by 2. So I'm going to get a decimal again, 11.5. Remainder, 1. And if you don't remember that, just 0.5 times 2 is 1. And now 11. Lost my pen for some reason. 11 divided by 2, which is 5.5. Remainder of 1. 5 divided by 2, which is 2.5. I got a remainder of 1. 2 divided by 2, which is 1. That went in perfectly, so a remainder of 0. 1 divided by 2, which is 0.5. Remainder of 1. I've got a number less than 1, so I know to stop. Again, I read these in the reverse order. 1, 0. Let's just shrink this down so we can see all the numbers. 1, 0, 1, 1, 1, 1, 2, 3, 4 ones, 1, 2, 3, 4 ones, and a 0 to the base 2. Scroll this back up. 1, 0, 1, 1, 1, 0, 2. 1, 0, 1, 1, 1, 0, 2. Those two numbers are the same. And they are. So that is my conversion. It will take some practice, but I do have the steps right now here in the video. I also have this document here. And that's attached. A little more stuff than we're going to do, but it's good information since you're going into computers, some kind of computer science or computer forensic program, something to do with computers. So binary additions notes are in here, binary subtraction, binary multiplication. So some notes to add. There is no homework problems of these or quiz problems, but I wanted to share this information with you that you may do at a more advanced level in some of your computer classes. So here is a good note for that. Also, I did not put it in here, but I have in the YouTube channel, and I will put this into my notes. So let's see, go to my channel. And this video will be uploaded to this shortly. Numbers and logic. That's right, I can find my playlist. Numbers and logic, there we go. So this is the link that's in our course page. This 30-minute video is really good by UET Education. Good. That's why I added it. I don't add a lot of videos that I don't make, but I got a couple that I think are really good. So this is a really good 30-minute lecture video on how to do.
So this point is
these, and so he explains it a little bit different than me. Same concept, but I like how he does it. So 2 great videos. This is very new to some of you, so I wanted to make sure you had all the resources that you need. Feel free to email me if you have any questions. I would recommend doing a couple of the homework problems before you do the quiz as always. All right, have a wonderful day.